Going to see about control system. First topic, steady state error. Before going to this steady state error, first we know the type number. Type number nothing but the number of poles of the loop transfer function lying at the origin. That is, in any transfer function, the poles lying at the origin, that the pole number is known as type number. If n equal to 0, then the system is type 0 system. If n is 1, type 1. If n is 2, it is a type 2. So first we know the type number means the number of poles lying at the origin is known as type number. Next, steady state error. Steady state error is a value of the error signal E of t when t tends to infinity. This steady state error is useful to measure the system accuracy. Based on this, measure the system accuracy. For example, it is a negative feedback system. Why? Because this is a feedback, here the negative sign, so negative feedback system. In negative feedback system, that is the closed loop transfer function means output C of S divided by, that is input R of S, equal to, that is the plant G of S divided by 1 plus, here negative feedback, so 1 plus G of S into feedback H of S. This is the closed loop transfer function. Here this is the error signal. Error signal is calculated based on this. We get E of S equal to R of S divided by 1 plus G of S into H of S. R of S is the input signal and G of S is a plant and H of S is a feedback. How we calculate the ESS? ESS equal to limit t tends to infinity E of t. That is the value of the error signal when t tends to infinity. According to the final value theorem, that is limit t tends to infinity f of t equal to limit s tends to 0 s into f of s. So based on this, limit t tends to infinity into e of t equal to limit s tends to 0 s into e of s. So e of s value equal to r of s divided by 1 plus g of s into h of s. So substitute this, limit t tends to 0 s into r of s divided by 1 plus g of s into h of s. Next, static error constant. Static error constant, there are three error constant. One is positional error constant, velocity error constant, and another one is acceleration error constant. So for type 0 system, when you input as unit step, we have a constant steady state error. For type 1 system, when the input is a ramp or velocity signal, we get a constant steady state error. For type 2, input signal is acceleration, we get a constant steady state error. So and mainly we remember this three formula, that is positional error constant, velocity and acceleration error constant. Mostly the TRB questions are based on the this error constant and ESS value. So Kp equal to S tends to 0. Positional means that is G of S into H of S. In case of velocity, S into G of S into H of S, Kb. And in case of acceleration error constant, Ka equal to limit S tends to 0 S square into G of S into H of S. Velocity yes, or a ramp signal means yes, and acceleration means here S square. Position means here no S, no is S. So for a type 0 system, ESS equal to 1 divided by 1 plus Kp, that is the constant value. For type 1 system, ESS equal to 1 divided by Kv. For type 2 system, ESS equal to 1 divided by Ka. So this is the introduction. We remember this table means we get easily solve the questions. So first, for type number 0, 1, 2, 3, error constant Kp, Kb and K, that is positional, velocity and acceleration error constant. For type 0 system, Kp is constant. For type 1 system, Kb is constant. For type 2, Ka is constant. Next, when the input is unit ramp, the ESS value equal to 1 divided by 1 plus Kp. When the input is unit ramp, the type 1 system 1 by Kv. When the input is unit parabolic, the type 2 system is 1 by Ka. This is the ESS value. So ESS value for unit step, unit ramp and unit parabolic. We remember this formula and this three formula Kp, Kv and Ka. Okay. Now we are going to solve one question. This is a question. This is one of the gate question. A ramp input applied to an unity feedback system results in 5% steady state error. The type number and zero frequency gain of the system are respectively. Okay, here the input is unit ramp. So when the input is unit ramp, we know the formula ESS equal to, when the input is unit ramp, that is 1 divided by KV. Okay, for type 1 system. Okay, for type 1 system, we know this formula. So here for what we asked, a ramp input applied to a unity feedback system which results in 5%. Now what is the type number? So for type 1 system, the ES is equal to 1 by KV. For type 0 system, ES is equal to 1 divided by 1 plus Kp. For type 2 system, ES is equal to 1 divided by Ka. Okay. Here the ramp input means KV. So which system the ramp 5% error? Type 1 system. So defaultly the type number is 1. Okay, next asking zero frequency gain. What is zero frequency gain? That is gain nothing but frequency. Zero frequency. So zero frequency f equal to 0. So what we did? 2 pi f equal to 0. The 2 pi f is omega equal to 0. So omega nothing but j omega. J omega nothing but s. S equal to 0. So for s equal to 0, what is that? A zero frequency gain. So Kv equal to limit s tends to 0, s into g of s into h of s. This is a formula. We already know that. That is s equal to 0. What is the value of Kv? So this for s equal to 0 means zero frequency gain. This is a zero frequency gain. The zero frequency gain nothing but Kv value. So how to calculate the Kv value? ES is equal to 1 divided by Kv. So substitute ESS value 0.05. Why? Because this is a 5%. So 0.05 equal to 1 divided by KV. KV equal to 20. So answer is 1 and 20. Okay. I think it is understood. If any doubt, please come and be. Thank you so much.